So now in this video we'll see Laplace transform of trigonometric functions. So Laplace transform of trigonometric functions. So whenever we have a trigonometric functions tackle, we need to use the trigonometric formulas. So already you guys have learned these formulas while finding the nth order derivative in the semester 1. Which are those formula? Basically we'll first see those formulas. So we hear what happening, since you know that you can find just the Laplace of one function at a time, but what happen if you have the product of two functions? So that happens only if you have such situations, sine A cos B wala formula. So here it is 2, so we can take that 2 in the right hand side. So 1 upon 2, the formula is sine of A plus B plus sine of A minus B. So this formula we will be needing. What is happening in this formula? Here you see that you have a product of two trigonometric function, and that product is get converted into two different terms. So that's why we want this formula. So very important formula. I request all the students to by heart this formula. Then next is, if angle of cos is greater than angle of sine. So in that case you can use the following formula, otherwise these two formulas are same. So now angle of cos is greater than the angle of sine, so that's why this is the order, otherwise these two formulas are same. So in the right hand side we'll be having sine of A plus B, and whenever the angle of cos is greater, so here we'll have minus sine, and the next term is sine of A minus B. So this formula we'll be using. And so next formula is, now these are the different trigonometric function. What happen if we have same trigonometric function? The formula for cos A cos B, whomsoever angle is bigger, you have to write that cosine function first. The formula is 1 upon 2 cos of A plus B plus cos of A minus B. So simply you just see that whenever there are two different angles, sine or cos, that time in the right hand side we have just sine, and whenever two angles are same, that cos or sine, you have cos of A, cos and cos only. Similarly at here, if you have sine A sine B, so that time whenever you have sine A sine B wala formula, you just keep minus sign at here. So this is very important, minus half, and then cos of A plus B minus cos of A minus B. If you do not write this minus at here, the formula will become like this: half times cos of A minus B minus times cos of A plus B. So this is how the formula will look like. So in all these formulas, what is happening, the product of trigonometric function is converting into an different terms. So joining is separated, simply happening at here, and directly finding Laplace of cos A cos B is not possible. But now since this cos A cos B is converted into cos of A plus B plus cos of A minus B, then you can take that half outside, then Laplace of cos of A plus B plus time Laplace of cos of A minus B will happen at here. So once while solving the example, you will understood these steps very clearly. And another formulas, another situation. So which is that situation? So this is the situation, sine square of angle. What is the formula? Sine square, because you don't have a formula for Laplace of sine square. So for that you have to use trigonometric formula. The formula is 1 minus cos 2 times of angle divided by 2. So please note this formula. Sine square of angle is always 1 minus cos 2 times of angle divided by 2. Similarly, we have a formula called cos square of angle. The formula is 1 plus cos 2 times of angle divided by 2. So we are going to use this formula very frequently in this Laplace transform and Fourier series. This formula, even while solving the integration also, you have to convert square function into an angle multiple. So we will be needing this here also. These formulas we will be needing in finding the integration. So please note these formulas. I will quickly give you one example how to find the Laplace transform of one simple example. I will take one simple example of Laplace transform in this situation. So I am just taking one example. Find Laplace transform of cos t cos 2t. This is simple example I am taking. So how to write the solution? So steps are very important, students. First, what you do, whatever function inside the Laplace, you just consider that function outside. So let consider that function. So cos t cos 2t, and now use the trigonometric formula, corresponding trigonometric formula. So cos a cos b वाला formula use होगा यहाँ पे. Since cos 2t is bigger, so you can rewrite this cos 2t into cos t. First time I am doing, so that's why I am writing briefly. Now cos a cos b वाला formula is half times cos of a plus b. So here it is a is 2t and b is just t, and then plus times cos of a minus b, so 2t minus t, bracket close, and this bracket is closed. And now we can write down 1 upon 2. This is cos of this 2t plus t is nothing but 3t, and then similarly here plus times cos of 2t minus t is nothing but t. So this is 2t minus t is nothing but t. So this is how the step will happen. So now simplify form of this function is this, and now finding the Laplace transform of this function is nothing but finding the Laplace transform of this function. So we are just finding the Laplace transform of here of our original function. So Laplace of cos t cos 2t, it is nothing but finding the Laplace of function inside. So that is 1 by 2 bracket cos 3t plus cos t bracket close bracket. Now you can use the linearity property. What is the linearity property says? It says that whatever constant that will come outside, so constant will come outside, and we have bracket and then Laplace. So the step will be, please mark the steps, you go slowly. Laplace of cos 3t at here plus cos t will happen. This is the step 1. Now again the next step. So here we have 1 by 2. Now again Laplace, 2 more functions in the bracket, so Laplace will apply. So L of first function, that is cos 3t, plus L of second function, that is cos t. So this is what the step happen at here, and now you can find the Laplace. So 1 upon 2 integration Laplace of cos 3t. So Laplace of cos 3t is simply by the formula s upon s square plus 3 square, plus again at here Laplace of cos t is by the formula s upon s square plus 1, and so this is what the required Laplace. So this is your final steps. So I hope you understood. Similarly you may have to tackle 3 functions at here. You may have to tackle 3 functions. So you may have to find the Laplace transform of such function like say sine t, cos phi t, sine 3t. So these 3 functions, you guys have already find the successive differentiation of these 3 functions at a time by using trigonometric formula consecutively. So same way you just use trigonometric formula consecutively at here and then apply linearity property of L. Now similarly there is a situation one needs to find the Laplace of say cos cube t. How you will find cos cube t? So say this is the second example I am taking, cos cube t ka Laplace. So you have to consider this cos cube of t and you have to write it in terms of multiple of angles. So here you can use the same one concept of same one concept, converting it into an exponential form, and then by using expansion of cos raised to n theta and sin raised to n theta. These concepts you have already learned in semester 1 mathematics. The same concepts you can use, or you can simply use the trigonometric formula. So whenever you have an odd power, so just take one, separate it. So just write one power of cos and then remaining power, that is e1. And now this cos t will be as it is, and you can write down this cos square is nothing but 1 plus cos 2t upon 2 by using trigonometric formula explained above. And now we can have this is nothing but cos t upon 2 plus this is cos t cos 2t upon 2. And now similarly, so this cos cube t will become, this cos cube t will become, this cos cube t will become cos t by 2. And again you can use the trigonometric formula here, so it becomes 1 upon 2 is as it is. And so the trigonometric formula for this two function is 1 upon 2 inside the bracket cos 3t plus cos t. And simply you can simplify this. This is nothing but cos t by 2 plus this 1 by 2 and this 1 by 2, it become 1 by 4 times cos 3t plus function plus 1 by 4 times cos t. So now these two functions are same, cos t by 2 and cos t, means cos t is common in them, so we can rewrite then this. So it becomes 3 by 4 times cos t plus this will become 1 by 4 times cos 3t. So finding the Laplace of cos cube of t is nothing but finding the Laplace of this function, that is 3 by 4 times cos t plus 1 by 4 times cos 3t. And now you can use the linearity property at here, so it will become 3 by 4 is constant, will come out Laplace of cos t plus again at here 1 by 4 will come out and Laplace of cos 3t. And now you can use the trigonometric formula. So Laplace formula 3 by 4 Laplace of cos t is simply s upon s square plus 1, and here 1 upon 4 is as it is. Laplace of cos 3t will be s upon s square plus 3 square. So this is how we are going to